Okay, here's a good question. It says a solution is created by adding 4 grams of 4.3 grams of barium hydroxide to make 500 mils of solution. So they want to know what the hydroxide ion concentration is and then what the pOH is. So first thing, I need to find how many moles. So I'm using this formula, 4.3 grams. Over here is the calculation for molar mass. So it's 171 grams per mole. The grams cancel. You come up with about this. So keep that number in your calculator. And then to find the concentration, you need to use this formula. So moles, got right from there, divided by the volume, which is right there, which you converted to liters. Excellent. And so you get a concentration of 0.05 moles per liter. Now that is of barium hydroxide. But I know that when I dissociate barium hydroxide, that I need to balance it. So let me write it. It'll be barium ions plus hydroxide ions. And if you balance it, there's a 2 there. So the concentration of barium hydroxide is 0.05. But if the ratio here is 1 to 2, then the concentration of hydroxide ions has to be double that. So it'd be 0.05 times 2. And I think that gives you 0.10 moles per liter for hydroxide ion concentration. Let me just get my calculator and make sure I go through all that. I want to make sure sig figs are good. So 4.3 divide 171.342, 0.0250 and other numbers after that, good. Divided by 0.5, 0.050, good, so that's concentration. And now I have to times that by 2. And I'm keeping this number in my calculator. So it's 0.10038,403. So that'll be the concentration of hydroxide ions. So now I need to find the pH. So the pH will be negative, not the pH, here I'm getting mixed up. This is hydroxide ion concentration, so I'm finding pOH. So it'll be negative log of the hydroxide ion concentration, or negative log of 0.10038,403. So let's not round any numbers till we get right down to the end. Okay, so what number do I have there? So I have to negative log that guy. I have to hit the log button and then hit a negative sign. Where's my negative sign? Oh, I got it. So this would be 0.998335385, and it's a pOH. And so up here I have 3 sig figs, 4 sig figs, so I got to go to the weakest 3 sig figs. So 3 sig figs for a pOH are 3 decimals after the decimal sign. So it'd be 0.99. This is less than 5, so this one would stay at 8. So that'll be your pOH. Okay, hopefully that sort of clarifies that for you. It's easy to forget that 2 there. You just sort of find moles, find concentration, and then plug into the formula. But you have to make sure you do that dissociation equation first so that you know what the ratio of concentration of the original substance to what it would be when it dissociates.